Hello everyone, let's study about telescope in this lecture. Telescope is an optical instrument which is used to see faraway objects. Suppose two objects are close by, then these objects would appear to be as one if they're very far away. In such case, telescope would resolve the objects. So telescope is basically used to see very far away objects. A telescope also consists of two lenses called as objective and then eyepiece. The objective is a lens which is used to see the object through which the light refracts, and eyepiece is the lens which is close to the eye. Unlike a compound microscope, in case of a telescope, the objective has a higher aperture because since the objects are far away, if the objective has a higher aperture, it will gather more and more light. To understand this, think of a star very far away from here. If you have a very small aperture, the amount of light falling from this would be negligible. Very small part of light falls on this. But think of a case where you have a bigger aperture like this. Then, in that case, more light would fall onto the objective. So the purpose is to gather more light so that we get a better view of the image. It's the reason that an objective has a higher aperture. And also the telescope what we are talking about here, or a telescope which uses two lenses, is called as an astronomical telescope. This is primarily used to focus on the astronomical objects. But the problem here is, in this telescope, the image what is obtained would be an inverted image. Now this won't be useful if we look at objects which are on the Earth's surface, like a building or a tree. Imagine a building being inverted, or imagine a tree being inverted. In such cases, we need to invert the image obtained so that we get an erect image. For that purpose, we use one more lens which would invert the image formed, and that is called as a terrestrial telescope. So telescope which uses three lenses is called as an terrestrial telescope. But what is given in class 12 syllabus is only the astronomical telescope. So we will talk only about that. Also recall that since we are using two lenses here, the magnification is equal to the product of each magnification. Suppose if the magnification of objective is m0 and the magnification of eyepiece is me, in that case the total magnification is given as m0 into me. So let's draw a diagram for the telescope to understand how it works. Again here we will draw just straight lines first. So let this be the objective center line. Suppose imagine that light is coming from an object which is far away. So light falls like this. Light refracts like this. We have two parallel rays. Light refracts here. And let's draw one more lenses stay center line, something of this kind. So here what is seen is, in this case, if we draw the lines backwards, because light refracts here, draw them backwards, these light rays will not meet. Let me finish this diagram, it becomes clear from there. As seen here, if you draw the light rays, then these light rays would not meet on this side. If you draw them backwards, the point where they meet, so this is where we get an image. Let's call this as A dash, B dash, because this point we get the image called as A and then B. Let's complete this lenses. So this would be the objective, and let's draw the eyepiece also. This will be the eyepiece. Draw them such a way that the objective looks much bigger than what is drawn here. So the image which is formed because of the objective acts like an object for the eyepiece, and finally the image is formed at the point B dash. Now the distance between the optic center of the objective to this point would be the focal length, which is called as f naught, because the object is coming, the light ray is coming from an object which is at infinity. Now for the eyepiece, this AB acts like an object. So distance from here to here would be UE, and the image is found finally at A dash B dash, so it becomes VE. So this would be its distance. Again here VE would have a limit from D to infinity. Let the focal length of this be f naught, and for this FE. Let the angle which the light rays makes with the object or objective be called as alpha, and this would be again alpha because these are opposite angles. Let the angle made by the image be called as beta. Now in this case, the magnification is defined as beta by alpha. That's what textbooks tells you, but the basic idea is magnification, as in any case, is given as angle subtended by the image by angle subtended by the object. That is what is M. Now in this case, for small angles, tan alpha would be same as alpha. So for small angles, alpha is same as tan alpha and beta is same as tan beta. With that in mind, you can find what is beta from here. So M is equal to, it will be tan beta, which would be minus of H, say we'll call as HI, or just call as minus of AB by sign convention by minus of UE by alpha would be minus of AB by F naught. Again from here, if you rewrite this, it's equal to minus of AB gets cancelled, and what you get would be F naught by UE is what M is. But recall that for a lens, 1 by F is 1 by V minus 1 by U. For the eyepiece, it becomes 1 by F suffix E, just put suffix E is what you get. And by sign convention, both VE and UE are negative. So we rewrite this as 1 by FE is equal to minus 1 by VE plus 1 by UE, putting sign conventions. Therefore 1 by UE from here is equal to 1 by FE plus 1 by VE. Putting it back in this expression for M, then what we get would be M is equal to minus of F naught, and 1 by U is equal to 1 by FE plus 1 by VE. This is what is magnification. Minus sign means that the image is inverted. Again here we had two cases. Case 1, image formed at D. It implies that VE is equal to D. You already put the sign convention here for V, so there's no need to put it back here. So M D is equal to minus of F naught 1 by Fe is 1 by D. If you pull out Fe from this equation, then MD is equal to minus of F naught by Fe becomes 1 plus Fe by D. So this is the magnification in case where image is formed at D. Suppose image is formed at infinity, that's a case 2. So case 2, do observe that we have the same template everywhere. That is, we define a general magnification and we find what is the magnification at 2 points, that is image formed at D and image formed at infinity. So image formed at infinity, which implies that VE tends to infinity. In that case, we get M infinite is equal to, from the same expression, if you put the value of V to be infinity, then 1 by infinity would be 0. So what we get is minus of F naught by Fe. And this is called as a condition where the object is at infinity and image formed at infinity is called as normal adjustment mode. This is what most books will be writing in the case of normal adjustment mode. Again here, as in the case of a compound microscope, even here also the distance between two lenses, that is from here to here, is called as length of the tube. Again from here, the length of the tube called as L. This L is equal to, it will be distance from here to here plus here to here, that will be F naught plus UE. Again here we want only the length, not with sign convention, so we just put mod here because anyway F naught is positive only. So this is called as length of the tube. As an exercise, you can find out what is the length of the tube when the image is formed at infinity, and also find out what is the length of the tube when the image is formed at infinity. In the first case, it's formed at near point, that is D, and here it is formed at infinity.